Good afternoon, everyone. Welcome to Build. This is the first Build conference that I've had the privilege of speaking at, and I can just say it's so exciting to be here. I can feel the energy in the conference. It really is an honor. I just want to thank everyone for spending time out of your busy schedule to come to Build and also to attend this particular talk. There are so many great speakers and amazing content going on all week. Before I begin, I just want to remind everyone we really value your feedback. This helps us to ensure that the content we give to you developers is always valuable and relevant. So please submit feedback. You get free stuff. What else can I say? OK, so I want to go back several years, back to 2008, when we still called Build the Professional Developers Conference. That year, we introduced Direct2D and DirectWrite. And these were two APIs in the DirectX family. At that time, DirectX had already been well established as the fastest way to render graphics in Windows. DirectX takes full advantage of the GPU, the graphics processing unit, on your device. And if you've ever played a 3D game on the Xbox or Windows, those are being powered by DirectX. And in a nutshell, our goal with Direct2D and DirectWrite was to take the power of DirectX and add the high-quality 2D drawing and text capabilities that you saw in APIs such as GDI+ and System.Drawing. So how well did we do with that goal? Well, today, Direct2D and DirectWrite are used everywhere from Mozilla Firefox to our own browsers, IE and Microsoft Edge, and also the entire Office suite of productivity applications. And every single app written on the universal Windows platform, whether it's XAML or HTML, runs on D2D and DWrite. So we think we've been very, very successful here. But as always, we knew there were things that we could improve. DirectX was designed to support the most complex and sophisticated applications in the world. And similarly, the API surface is also very complex. And frankly, it takes a very long time to master. So we have many, many stories on the graphics team where developers come to us and they say, look, I get the benefit of DirectX. It's going to give me the fastest performance and the highest visual fidelity. But I'm not trying to build the next Halo. I have like a week to finish this application. I really don't have the time to become a graphics expert and ramp up on DirectX just to get my application to run. And we really didn't have a great story for these developers. So it was with stories like these in mind that we set out to build Win2D. Win2D is a 2D drawing library that combines the power of DirectX with the ease of use from .NET-level APIs. And it combines them into one API offering for your Windows Universal apps. So as a 2D drawing library, we can do things such as draw text, shapes, 2D geometry, images, and also many more sophisticated things such as image effects, advanced blending, opacity masks, and things like that. Win2D is part of the universal Windows platform. And this means that it will run on any device that is running Windows 10. In addition, we also specifically support Windows and Windows Phone 8.1. You can write your Win2D app using C++, C#, or any other CLR language. And finally, you can get Win2D today on NuGet.org. And if you're targeting a Windows 8.1 or Windows Phone 8.1 project, you can actually ship your app on the store successfully today. Just as a note for Windows 10, we're waiting for the updated release of the Windows 10 SDK and latest flighted bits before we release a up-to-date Win2D version for Windows 10. So I'm going to give you a quick demo of some of the basic functionality that Win2D provides to give you a better idea of what we're talking about. OK. So what I'm launching here is an application called the Win2D Example Gallery. This is a sample app that we wrote. And it showcases some of the API capabilities you get, and also some more end-to-end scenarios that you can accomplish using Win2D. And in fact, we actually shipped this on the Windows and Windows Phone stores as a proof of concept So if you want, you can download it and follow along. So I'm going to pretend that all of you guys who are like staring at your laptops and phones are actually just using Win2D. Don't break my heart, please. So let's start with some basic functionality. Basic shapes, such as lines, rectangles, and circles. So here you can see we're doing some very basic styling. We've colored each line with a different color. But Win2D obviously gives you much more powerful functionality to control the appearance of geometry. So let's take a look at a bit of that. So obviously you can control the color and thickness of your lines. But in particular for strokes, we can change a solid line to dashes or dots or combinations of the above. And we can also control the appearance of each dash or dot. Win2D also supports geometry, 2D geometry of basically arbitrary complexity. So what you see here, I've drawn a bunch of shapes, square, circle, triangle, and the star. And I've defined the star by combining 10 different line segments. And just for clarity's sake, I've told Win2D to outline each shape in some red. And the important thing here is that if I tell Win2D to combine these into a single shape object, a single geometry, it's not just pasting each shape on top of one another and calling it a day. It's actually recalculating the mathematical vector definitions. So for example, if I tell it to only draw the outline, you can see that we are not including the lines where the star intersects with the other shapes. Next up, we have text. So text fundamentally is just a specialized form of geometry. So you can see here that we've stylized it using a geometry option. We have a gradient that goes from red all the way to green down at the bottom. But because of this text, we have a lot of specialized functionality as well. For example, here I've told Win2D to draw the layout bounds of every single character. That basically is the positioning and spacing of every character. And we can use this to implement functionality such as hit testing or drag to select, as you can see here. Win2D is fully Unicode compliant, and you can properly display your bidirectional or top-down text, as you can see here with this Chinese script. And once again, because it is text, you get layout options just as you might expect. And finally, we have a particle system demo. So this is something that's a little more end-to-end. We're drawing something that looks a little fancy on the screen. Fundamentally, what we're doing here, we're just loading a bitmap of a smoke particle and a flame particle, and we're creating many instances of that bitmap, and then we're blending them together and animating them across the screen. Okay, so what kind of scenarios do we think will really benefit from Win2D? Of course, Win2D is a general purpose drawing API, so we really think the sky is the limit. First, we have data visualization. This is if you have tens of thousands of data points and you want to render them on screen, or maybe you have an architectural diagram or some kind of sophisticated technical drawing. Second are creative apps. This can include a photo editor app, maybe a drawing application, or a 2D or casual game. You want sophisticated visuals, but you don't necessarily need the full power of a 3D engine. And finally, we have custom controls. So for example, if you're trying to extend the XAML toolkit. Now, XAML obviously has very powerful built-in and custom control functionality. But later in this talk, you'll see some areas where you may want to go beyond its capabilities and use Win2D. OK, so by now, you should have a decent idea of what Win2D can do. But why do you care? And this is an important question because, as you know, there are many, many excellent graphics API solutions out there, both made by Microsoft and by third parties. So what makes Win2D special? If you can remember one slide from this presentation, let this be it. The 4 reasons why we think that Win2D is an excellent tool that you should consider. It is super easy to use, just like all the .NET level APIs that you know and love. It offers extremely fast performance, and it scales to the complexity of your visuals. It has powerful, comprehensive 2D drawing capabilities, and it has some really unique graphical tricks that we think you can use to make your Windows app really shine on the store. And finally, by being open source, we can provide you, our developer community, with a high level of transparency and flexibility. So let's look at ease of use. We designed Win2D to encourage your creativity and to let you explore and experiment as you're building out your graphics. So what this means is you should be able to come up with some kind of really cool visual idea in your mind, implement it in your code, and then iteratively add and tweak and modify things as you come up with new ideas, and to do that with minimal friction and frustration. So instead of just talking to some slides, I think you guys would probably rather see some live coding. And because I enjoy tempting the demo gods, I will oblige. In the grand tradition of API introductions, we're going to build a Hello World app using Win2D. And I'm going to show you how easy it is to use Win2D to get started, to build some basic graphics, and to quickly build up from there and do some more sophisticated things. So what we have here is a blank C# universal Windows app project. In the interest of time, I've added a couple small things first. So for example, you can see that I've added a couple namespaces. I have a few random number helpers, and these we'll use later in the talk. And finally, I have this cute photo of some penguins. So the first thing that you need to know when you're using Win2D is that we don't ship Inbox with the Windows 10 SDK. We ship as a NuGet package. And if you've ever used NuGet packages before, you know that adding them to your project is very, very simple. Let's go ahead and right-click on the project. We say Manage NuGet Packages. Now, for the purposes of this demo, I've already installed Win2D, which you can see here, from a local package source. But normally, you would go to nuget.org to download it. And you can see in our references, there's Microsoft.graphics.canvas, and that's the namespace where all of the Win2D functionality lives. So now that we have NuGet, we need someplace to draw the content. And so I'm going to insert a new Win2D. Sorry, now that we have Win2D, we need to draw some content. Before I add a control, we're just going to tell XAML what namespace we're looking at. So graphics.canvas.ui.xaml. And now that we have that out of the way, let's go ahead and add a canvas control. So canvas control is where you draw all your canvas, where you draw all your content, obviously. Canvas control provides us with an event called draw. And it will call this, it will raise this event whenever your application needs to redraw its content. So this includes things where you're resizing the window, or maybe the user's manipulated some content on the screen. And I'll let it auto-insert the handler, close that out. Great. So if we go to our code behind, you can see it's added the signature for the method for the event handler. So it passes us two arguments. The first one is just the canvas control that raised the event. And the second argument is this canvas draw event args. So if we take canvas draw event args, it has this member called drawing session. And this is of type canvas drawing session. The canvas drawing session class is where most of the basic rendering functionality that you need is located. This includes methods like draw line or draw image. Or in our case, we're going to draw text. So what do we pass in here? Well, obviously, we need our famous hello world. It's asking for a position. I don't want to put in a vector 2. I'm just going to put in 2 floats. So this tells us where we want to draw the text. And finally, we need to give it a color. So I'm going to give it a predefined color. OK. And there we go. And I feel like every time I press compile on stage, I have to sacrifice a goat to the demo gods or something. So let's keep our fingers crossed. It is churning away, registering the application. We know. Wow, that's a long loading screen. OK, there we go. Hello, world. And so the important thing here is that apart from that boilerplate that we added, we have 1 line of C# and 1 line of XAML. And it can't really get much simpler than that. Win2D makes this kind of simple startup possible because we handle much of the background functionality and startup code that you would normally need to write. And so when I say that point, I'm really talking about to those of you who've used DirectX in your apps. DirectX has this philosophy where you are, as the developer, are in total control over the behavior of the API and the graphics hardware. But on the flip side, this means you literally have to write hundreds and hundreds of lines of code to specify the exact behavior you want just to get to, say, the first triangle drawn on the screen. So in Win2D's case, we know all about these best practices. We also know that in most common use cases, you guys are using the exact same calling pattern again and again. And so we really can just do that for you. OK, so Hello World is interesting and all that. I think you guys have seen that many, many times. I personally think just plain black and white text is a little bit boring. So let's change things up a little bit. Let's draw a bunch of, whoops, that's not what we do. For int I equals 0. I remember my for loops. So we'll do 200 iterations of this. I also remember my parentheses. So we're drawing 200 lines. Let's give it a random position. So we're going to use some of those helpers I did. Random x and random y just give us two random floats. And instead of having a pre-specified color, we're going to use the from argb color.from argb helper. This lets us define a color using alpha, red, green, blue values from 0 to 255. Alpha is going to be fully opaque, but for the other three color channels, we're going to use just a random number. Yes. OK, one more goat in the sacrificial pit. And there we go. OK, so that's a little more interesting, right? We have a bunch of hello worlds. They all look a little different. Once again, with the for loop, 2 lines of C#, 1 line of XAML. So as I was modifying the draw text method, you might have been wondering, hey, wait a second. Like, all you're doing is changing the position and color. Like, can I do like size or font or like layout, like other advanced things? The answer is yes, of course. We let you control all of that. So for example, if I activate IntelliSense here, you can see we have a lot of overloads for draw text. It might be a little hard to see on the screen, but for example, this one is more advanced, and it provides this last class that you pass in called canvas text format. And in particular, that's what you use to control font family, font weight, things like that. However, in my case, I'm just doing hello world. I don't really care about font. I just wanted some reasonable defaults. I didn't have to enter all the parameters. And what Win2D does for me is it gives me these choices of APIs that give me just the right level of control for my scenario. So for simple cases like this one, the code should be very, very simple. And as I make things more sophisticated in my app, the API should scale in complexity as well. All right, so I personally like it when things move around on the screen. So let's do some animation. We're going to go back into our XAML, and I'm going to replace the canvas control with the canvas animated control. So canvas control is designed for mostly static content. So this is a typical mainstream app where you don't want to redraw unless something has happened to invalidate that content. So that's what we did previously. Canvas animated control, on the other hand, is designed for continually changing content. So this might be like a 2D game or some kind of animation. And you want the control to raise the draw event on a regular interval. So under the covers, canvas animated control actually behaves very differently from canvas control. If you've used DirectX to do this, you know that you're running on a background thread, you have different integration points with XAML, you have to change the way your message loop works. Once again, because we're Win2D, we do all this for you, and we can give the developer a very consistent experience between these different modes of operation. So for example, canvas animated control has a draw event, right? And we'll see it looks basically identical to the normal canvas control draw event. By default, we get drawn 60 times per second. That's every 16 milliseconds. And so I don't even need to specify that. So what I can literally do, I can take my existing draw code, cut it out, plop it in a new canvas animated control event handler. Let's just delete that. And let's see what we have. All right, so 60 frames a second. We have a lot of drawn animated text on the screen. Of course, you might wonder, this kind of looks really weird, but 2 lines of code, 1 line of markup. I'm going to do one more thing. So one of the more advanced functionality that you get from Win2D are image brushes. A brush is basically something that can paint the interior of a geometry or region. And so, for example, when I specified the colors in this example right now, it's actually creating a solid color brush underneath the covers. An image brush, consequently, is just a brush where you get the content from an image that you load from disk. So in the interest of time, I'm going to cheat a little now. I'm going to take some pre-written code. First, we have a couple of namespaces. We are going to add a new event called create resources. So create resources is where we recommend you create your Win2D resources. If you notice now, we're calling draw 60 times a second, so it probably doesn't make sense for you to access the disk and load an image and create an image rush every frame. Instead, create resources is the place to do that. And finally, I'm going to paste in the pre-built handler for create resources. So what we're doing here, canvas animated control create resources. What this line is doing, as you know, loading resources from disk is an asynchronous operation. And so we're telling Win2D when we are done, when we are completed loading any asynchronous resources. And we call a method that we've defined load resources async. It's right here. And we're just doing two things here. First, we're loading the image from disk. We're creating this thing called a canvas bitmap. And then we're creating our canvas image brush from that image. So now that I have the resources loaded, let's change our actual draw code. So I used to have a solid color that I defined, but now I'm just going to put in the image brush. And because this is a more sophisticated scenario, Win2D asks us to put a canvas text format class. Once again, I don't really care, so we're just going to tell it, give me a default one. All right, so that's not too bad, right? What we see here, every time we call draw text, you can imagine it acting like a stencil where the penguin image can peek out from behind. And we're doing this 200 times per frame, 60 frames per second. And as before, just a few lines of C# code, one line of XAML. We were able to build this up very quickly and with minimal fuss. So what we saw here, Win2D lets you write much less code to get to your drawing, the interesting part, because we handle a lot of the heavy lifting for you. And also, we give you simple API choices for when you only want simple functionality, and we scale along with the needs of the developer when you want to do more advanced things. So next up is performance. So what? It's easy to use. What happens if it's not fast enough to keep up with my needs? So spoiler alert, we are very fast. So I'll demonstrate that by showing you, by showing you a modified version of our Hello World application in Win2D. So we're drawing rectangles instead of draw text here, so you can kind of see the visual difference more. And we're drawing 500 of these squares every frame. And it's important to note that we can actually go much, much faster than this. We're drawing at 16 milliseconds per frame. That's 60 frames a second. But we're running on this little Surface Pro 3. And this is a handy little dock made by the friendly guys at the Microsoft Maker Garage, so I can raise up the screen. But this is just a regular Surface Pro 3. It's this very lightweight, battery life optimized device. And we're getting a solid 60 frames per second. And in fact, the Surface Pro 3's LCD screen, as with most laptops, is limited to 16 milliseconds per update, 60 frames per second. And so Windows actually doesn't allow us to render any faster because it really makes no visual difference. So because we're on the graphics team, we like more power. Let's crank up the number of draw calls. Let's bring it up to something truly ridiculous here. When we get to around 10,000 frames, 10,000 draws per frame, this is really kind of in the territory of 3D games here, AAA 3D games. And even with this ridiculous number of draw calls, by the way, please never do this. You can see the image is basically completely filled in. Please just draw image once and be done with it. Don't do what I'm doing here. But even with this stupid scenario, we're getting about a little over 25 frames per second. That's 250 to 300,000 squares with little penguin images drawn per second. So that's pretty good. So I want you to remember that, and it's fluctuating a little bit. So 10,000 draw calls per frame, and maybe it was 35 to 40 milliseconds. So of course the question is, can we do any better if we're going to use native DirectX, right? That's the gold standard. So what I have here is I have the exact same scenario, but we're using Direct2D. Same penguin, same squares. Right? And let's go ahead and bump it up to something stupid. Probably shouldn't say that word, something ridiculous. And as you see here, with native Direct2D, we're fluctuating, and it's a little lower, but we're getting around 35 frames per second. So almost 300,000 squares drawn per second as before. But the important thing to note, so that it's fluctuating a little more. The important thing to note, first of all, performance measurements are always highly, highly dependent on the scenario that you're accomplishing and the hardware that you're running on. This is just one particular micro benchmark. But the message I hope you guys get is that for most common scenarios, we do not expect you to see any significant performance difference between Win2D and Direct2D. So how do we do that? Well, as you probably guessed, Win2D is built on Direct2D. We were built 100% on DirectX, and specifically focusing, as I mentioned at the beginning of the talk, Direct2D and DirectWrite. And as I said before, DirectX is the fastest way to do graphics on Windows. It is the foundational layer for graphics. Everything that renders to the screen in Windows, every line of text, every line, uses Direct2D and DirectWrite. Now, the DirectX team, with every release, invests a significant amount of effort to squeeze every last bit of performance out of that graphics hardware. And so all of this goodness that we've baked into the platform, you get for free when you use Win2D. So if you might be wondering, wait a second, Simon, you mentioned that XAML is also built on DirectX. So doesn't that also mean it's super fast? The answer is yes. It's a matter of scenario. XAML is optimized for everyday user interface scenarios. And it provides some really powerful functionality on top of 2D drawing. These are things like data binding and declarative animations, retain mode layout. This is a lot of very powerful stuff. And even then, it gives you great performance, like I said, in those typical UI scenarios. But let's say you were doing 10,000 squares with penguins flying around. XAML is not exactly designed to do that. Win2D here scales better with those kinds of very intensive graphical operations. So Win2D, on the other hand, we give you easy-to-use 2D rendering and very little else. For example, we don't give any of those services that I just mentioned. And this lets us focus all of our energy on being a very thin and very low overhead layer on top of Direct2D. OK. So we've shown that it's fast, and it is easy to use, and it scales with your demanding performance requirements. But I've only shown you like text and lines and some basic shapes. Does it meet all the needs that you have for more sophisticated rendering? So just like how I said, being built on Direct2D and DirectWrite gives us very, very good performance, it gives us very comprehensive drawing capabilities as well. I mentioned earlier how everything on Windows, and up to the most complex of apps like Office, uses DirectWrite and D2D for rendering. And with Win2D, we had a philosophy where if it's exposed in D2D and it's rendering related, we want to have it in Win2D. If it's exposed in Direct2D, sorry, and it's rendering related, we want to also have it in Win2D. So almost everything that you can do in Direct2D and DirectWrite is in Win2D. So I want to talk now about 3 specific areas in Win2D that we think are particularly cool, and we think that you can use to differentiate your apps on the Windows Store. The first is image effects. If you're not familiar with these, image effects are also known as filter effects, and they are a graphical transformation that you apply on pixel data. So here I have 3 common examples: discrete transfer, morphology, and Gaussian blur. So Win2D provides a library of over 30 built-in effects. But the real power you get with effects are that you can combine them together into chains and graphs and animate them in real time. All right, let's take a look at some effects. So we go back to the example gallery. So here, for example, we have something basic, Gaussian blur, and we're just changing the blur radius over time. Saturation. Blend is a little more complex. It takes 2 inputs. We have all of the standard ported off blend modes, composite modes, arithmetic composite. Morphology, as we saw before, this lets you thicken or thin the lines in your image. We have some more sophisticated things. Here's lighting. What we're doing is we're using the image of our intrepid mascot, Cinnamon, and we're extracting, we're basically creating a height map based on the luminance, and then we're using that to light. And then we have something like displacement map. Displacement map and also the lighting effects that you saw in that previous demo. These are actually combinations of multiple effects that we use together. Specifically here for displacement map, we're using a transform 2D effect, a turbulence effect, and a displacement map effect. So what exactly does that mean when I say we combine multiple effects together? Effects take inputs, right? And the key thing is that the input to an effect can be an image, such as the source image, but it also can be another effect, such as you see with turbulence, which feeds into 2D transform, which feeds into displacement map. So in this case, we start with turbulence, and turbulence generates Perlin noise. And that's basically pseudo-random noise that has this kind of smooth appearance. And you see this often in like video games and special effects in movies. The displacement map effect takes the bitmap of that turbulence field, and it uses it to warp the image. And you can see in the output. We get the animation by sticking this 2D transform effect between turbulence and displacement map. And you can imagine that as like if I have this rippled pane of glass in front of my face, so that's the turbulence noise, and I'm viewing the distorted scene in front of me, and then I kind of just like move the pane of glass around like this, right? You can imagine the world in front of you will also ripple over time. So the specifics of this scenario aren't that important. The key takeaway is that these effects are powerful on their own, but you can combine them together and then animate their properties in real time to get some really clever visual tricks. One thing I want to emphasize with effects is that you commonly call them image effects, but they can be applied to any Win2D content. Geometry, text, images, other effects, they're all the same. So we now go to the burning text demo. This is something you might have seen if you've attended a Direct2D talk in recent years. We can't get over this demo. This is applying no less than 10 separate effects to give this kind of shimmering flame. But the important thing here is that this is just text, and we are doing this dynamically in real time, so we can replace this with anything we want. Right? For reference, to implement this, it took about 250 lines of C# and XAML code. To do this in native Direct2D, it takes something like over 1,600 lines of C++. And no, this is not an endorsement to apply burning text to all your text, unless perhaps you're doing like a late 90s heavy metal band app or something. These are not new design guidelines for universal Windows apps. OK, next up for powerful functionality, we have DirectX interop. So we designed Win2D to give you guys a comprehensive set of 2D drawing functionality. But we know that the most successful apps are always pushing the boundaries of what's possible with our API surface. And what we want to avoid is having like a quote-unquote walled garden. And this is where if you are doing things that we've designed for in our API, it's easy to use, it's beautiful, sunshine, rainbow, flowers everywhere. But the instant that you try to go outside of that beaten path, you like fall off this like cliff of difficulty of use. Or even worse, it's just not possible to do what you want using our API. So as you know, Win2D is built on top of DirectX. And so our solution to the walled garden problem is we make it very, very straightforward for you to take a Win2D object and extract the underlying DirectX object that it's built on. And also vice versa, you can take any DirectX resource, D2D, D3D, DXGI, whatever you have, and you can easily construct the corresponding Win2D wrapper to use in Win2D. In this way, you get access to all of the DirectX API surface. And the most important thing is that you can leverage your existing DirectX or Win2D codebase, mix in usage of the other API, and you don't need to throw out your existing code. So let's show you with a concrete example. So we have here the kind of standard 3D demo, a 3D spinning teapot. And this is being rendered in Direct3D. It's using the excellent DirectX SDK toolkit to help us render these things. And what we're doing here, one thing that Direct3D doesn't have great functionality for is rich text rendering, so like anti-aliasing, layout, fonts, things like that. And so what we've done is we used Win2D. We've just rendered some text, and we're animating it up over time. And we use that as a texture in Direct3D with every frame. And so we're just mapping it onto the teapot. Then what we're doing, we take the render target in Direct3D, and we bring that back into Win2D. And we're using Win2D to apply this bloom post-processing effect. So I'll bump up the intensity right here. It's a little too high. And so what you see here, we can go from Win2D, and when we want to go a little further, maybe add some 3D functionality, we go into Direct3D, no loss of code. Or we can start with Direct3D, and if we want to take advantage of something that is easy, effects in Win2D, we can also go that way, and no loss of code. OK, last up for powerful functionality, we have integration with video and composition Windows 10 APIs. Video and composition are two areas that are closely related with 2D graphics. And so we know that you guys will probably want to use these capabilities together. Even though Win2D is not part of the inbox Windows SDK, and we ship as a NuGet package, we've worked closely with the corresponding platform teams to make sure that you can seamlessly use your Win2D content with video and composition scenarios. So the first new API is the new Visual Layer API, which is part of the windows.ui.composition namespace. This API is in an early preview state for build, but it's basically a lightweight way for you to add animations and effects and manipulations to your UI. One of the most important things it adds is this thing called independent animations. If you've ever written an HTML or XAML app before, you might have used independent animations. These are basically a way to guarantee that even if your app's main thread, the UI thread, is busy doing calculations or rendering graphics, the animations will continue to be smooth and glitch-free, and the any user interactions, and your app will still be able to respond to user interactions, like stick to your finger touch. We designed Win2D so that you can take any Win2D content and use it as an input into the visual layer. And this means you get the best of both worlds. Win2D's immediate mode 2D rendering and the composition API's retained mode functionality. The second API I want to talk about is iBasic Video Effect. This is in the Windows Media Effects namespace. iBasic Video Effect is a completely new paradigm for processing video in Windows 10. You implement an iBasic Video Effect interface, and you can use that effect to transform any video on the system. That includes downloaded videos on disk, videos that you're streaming from the web, or even videos that you're capturing live from a video camera. And as before, we designed Win2D so that I could take a captured video frame, process it however I liked using Win2D, and put that back into the media pipeline. So let me show you what I'm talking about. All right, so that's a little washed out, but you can see me, right? This is just a standard webcam app. It's taking live captured video and rendering it onto the screen. But let's take some Win2D content and put it on here. Let's take that displacement map that we looked at earlier, and voila, right? We can do whatever kind of crazy things we want using real-time video. And wow, I look really ugly here. I'm going to stop that. Not very photogenic, apparently. We think this is a great example of combining two complementary APIs, Win2D and video effects, and using them to just open up like crazy, crazy new scenarios that really weren't possible before. So one more, for example. Here, I've taken my video scene, right? I've chopped it up into these little square tiles, and every frame, I'm rotating and scaling these tiles, right? OK, now I'm getting a little dizzy. Stop that. So how hard was that to do? The rotated tiles effect, that last one you saw, including the namespaces and all the boilerplate for the iBasic Video Effect implementation, is just under 100 lines of C# code. In comparison, if you were to use native Direct2D, C++, and Media Foundation, so that's the native component that underlies the media APIs. And just to do something simple like a grayscale, you would need over 2,000 lines of C++ code. 100 lines versus 2,000. Now that's powerful capabilities that using these Windows 10 APIs can give to you. All right. Last up, we have open source. So open source is not exactly a new thing at Microsoft. And you can see over time, we have released more things under open source licenses. We have the .NET Foundation. We have Win.js. And Win2D we first announced it in September of 2014. And we started shipping our first NuGet packages a couple months later. And we're proud that from day one, every single line of code that goes into Win2D has been available on GitHub under the Apache 2.0 license. So we think that making Win2D open source gives you guys two key benefits. The first one is that we can be highly flexible and responsive to you. In fact, we push new NuGet package builds and push new code to GitHub every single 2 weeks. Second, we can be highly transparent. As I said, you can browse every single line of source code on GitHub. You can build everything from Win2D itself to the documentation to the example gallery sample app because our toolchain is 100% public tooling. You also know exactly what we plan to do because our backlog is fully public. So with Win2D, we want to engage strongly with our developer community. We want this to be a two-way conversation. We want you to send comments on our blog. If you have any questions or you found bugs and problems, we want you to file issues on GitHub. If you have bug fixes or new things you want to add to Win2D, submit a patch. We have a contributor agreement, very quick to sign. We want to know what you guys think. Tell us what you like. Tell us what's hard. Tell us what kind of scenarios you want to be able to do in Win2D. We've built this API for you, and it really depends on what you guys think about it. OK, so what's next for Win2D? First up, we want to finish support for the universal Windows platform. And what this means is we want to reach the same level of API stability and feature completeness as we have with the Windows 8.1 version. Second, we want to reach an API stable 1.0 release for people who don't want to deal with API breaking changes. If you go on NuGet today, you'll see that the current version is either 0.17 or 0.18. So we're waiting for the official Windows, the next Windows flight to go out before we push our next release. So we stand by the quality and stability of Win2D, regardless of the version number. But what the version number means is that until we declare 1.0, we want to have the ability to respond to developer feedback. And so we're not locking down on our API surface. Once we reach 1.0, we will have an API stable 1.x release branch, in addition to future parallel development branches, where we will continue to make breaking changes. And the last thing that we're looking to do is to expose all this new goodness that has come online in Windows 10. The Direct2D and DirectWrite team has been very busy adding a lot of new goodies. You should go see my colleague Anthony Hodgson's talk on Friday if you want to learn more. And today, we don't expose any of that. Even the UWP version only exposes DirectX features from Windows 8.1. So we hope to get these all done in the Windows 10 RTM timeframe. But as always, it depends completely on feedback from you. We want to know, is this the right priority of things? Are these even the things that you want us to work on? OK, so I think you guys have a pretty good answer to this question. We're easy, we're super fast, we have some eye-dropping visual capabilities, and we're transparent and responsive. So as you guys continue through the rest of build and start thinking about that next killer Windows app that you're going to write, I hope you keep these 3 points in mind. Win2D is DirectX for the rest of us. It combines the ease of use that you expect with extremely fast performance and some killer drawing capabilities. If you're building for Windows 8.1, you can ship a Win2D app on the store today. And very soon, you'll be able to do so for Windows 10. And finally, we want your help and input in bringing Win2D to the next level. So here we have all the resources, everything that I talked about in my presentation you can find here. And we also have related sessions. I highly, highly encourage you, if you're interested in either the composition APIs or the video and audio editing APIs, to check out these talks. So on behalf of the Win2D team, I just want to thank you once again for coming and spending your time here. We are really, really looking forward to see what you guys think about this API and what kind of amazing graphical experiences you can dream up. Thank you. So, yep, if you have any questions, we have 2 mics on either side.
Sure. 2 questions. Yes. On the DX support, do you support from 9C, or what's the minimum version of the DX?
So the question was, what is the minimum version of DirectX that we support? So Direct2D and DirectWrite are built on DirectX 11. So we require, also if you're writing for the universal Windows platform, you write against the DirectX 11 API. So if you're not familiar, DirectX 11 has this feature called feature levels, and this allows you to use the DirectX 11 API, but to target hardware that may not be capable of exposing all the DirectX 11 features. So for example, phones, like if you have the Qualcomm chipset like on Windows phones, most of those are DirectX feature level 9.3. But you still use the DirectX 11 API, but there are ways to just restrict the API feature usage to what the chipset can support.
Okay, thank you. How about OS? Windows 7?
No, we support Windows 8.1 and above. Okay. The strategy that we have, we would really like everyone to upgrade from Windows 7 to Windows 10.
Okay, thank you.
Do you have any plans to add support for like traditional desktop applications? I mean, because that's our main need. I mean, we're doing like financial applications where we need to update the screen very quickly and efficiently and draw lots of text. And right now, I've been experimenting and doing that with like using DX Sharp and the Direct2D library, and basically making a texture and then rendering that in WPF.
Right.
But it seems like this would be a nice library, but it looks like it's only for the Universal Windows platform, which keeps us from using all the other libraries we need. So.
Yes. So we focused on obviously building UWP support first. We should talk. This is something we always want to know what you guys are trying to do with your APIs. Why don't after this talk, if you have time, we should talk offline.
Sure.
And see.
Yeah. Is there an easy example of saving out the results on the canvas to a file or something like that?
Yep, that's a great question. We have a helper. I'm trying to remember exactly what the name is, but basically it's a single step, just like load image async. We have a save image async, and you can just save out all that content. Yes.
Do you have some idea about performance comparison to using a writable bitmap, or is that not a reasonable comparison to draw?
Are you specifically this is XAML's writable bitmap?
Yeah.
Yeah. So I'm not an expert in that field. I can try to hook you up with the XAML people, but one of the things, for example, the writable bitmap is fundamentally a CPU-based bitmap. Like you can access pixels directly. So one of the things you'll notice to maintain maximum performance, you want to use an API that's geared for GPU-based rendering. So it depends on your scenario, but sorry, please. Oh, sorry. So yeah, it depends on your scenario, but they are slightly different scenarios there.
Sure.
So we can talk after if you want to get more information.
Thanks.
Oh, sorry. One thing before I forget. Yes, please give us feedback. Free stuff. Yes.
Is there any support for things other than graphics, for instance, like password cracking or stuff that uses the GPU more than the CPU?
So I assume, is that something like GPU kind of things?
Sure.
It might be possible. That's not one of the scenarios that we had in mind. For example, one thing that you might want for GPU is direct access to pixel or compute shaders in this case.
Sure.
Direct2D, so Direct2D actually does offer a way to write to pixel shaders or compute shaders, but at this point, that's not exposed in Win2D. We would love to hear if you have some super idea that I want to be able to do this, but I want C#, I want high performance. Send us feedback. It'd be really interesting to see.
Okay.
Any other questions? Okay. Well, I guess we'll close it a bit early. I want to just thank everyone once again on behalf of the Win2D team. So I will be in the Windows Insider Lounge for around an hour to 90 minutes after this, if you want to talk to me or ask me more questions. You'll also be able to find me tomorrow afternoon in the expert zone, the download and expert zone, so if you want to talk to me there. Also, if you want to learn more about the Win2D API and try to play around with it, you should head over to the Quick Start Challenge Zone. We have a Win2D Quick Start lesson. It takes about 15 to 30 minutes, and you can build an app in Win2D that looks pretty similar to the Hello World demo that I showed on stage. Thanks again, and enjoy the rest of Build.